to just reason properly and say, yeah. So, I mean, for those of you who answered that she was a feminist bank teller, what was going through your heads at the time?
I mean,
like, don't feel bad. Most people get it wrong. Like, most people by far get it wrong. And so this has nothing bad about you. This is just like how we think. And so, like, what was going through your heads as you were making that choice?
I mean, the description tends to indicate someone who is a feminist. So I guess the automatic trigger was just along the idea of like sounds like an active person. Sounds like someone who is concerned with that kind of thing. So I think the automatic jump was it sounds believable for her to be active in the feminist movement, given that.
All right, and so for the people who answered correctly, what was going through your heads as you were making the decision? Like, what made you to say that's more likely?
I was curious about the phrasing, whether you were saying, is it more likely that she is a bank teller, feminist or not, or is she a feminist bank teller? And I kind of assumed that the more plausible reading was that is she a bank teller, period, in which case it was just obvious that that was more likely than her being a feminist bank teller, because even if she was a feminist bank teller, she'd be a bank teller.
Yeah. Okay, yeah. And so that's, yeah, there's been some concern in these studies. Yeah, there's been some concern in these studies that people don't fully get the like and meaning conjunction logically, which I think is a legitimate concern and something that we kind of saw here. But yeah, those two thought processes I think are basically the two standard ones that you see. What Alla and Ramya were exhibiting is a phenomenon called base rate neglect, which is where you, when answering a question, you ignore the base rate of a population when making your decision. So you're only making your decision on the information actually presented to you, in this case, this personality description. So for the second question, this was at Tom, the college professor or truck driver. For those of you who answered college professor, what was going through your head?
I figured the description was close enough to college professor to, I was thinking that there are probably like how many times more truck drivers than college professors. I figured it would be a handful of times more, maybe a few dozen times more.
Remember, I said classics professor at Ivy League school.
Okay, classics professor. That I missed. But just that description was tight enough to push it to lower to make the likelihood of truck driver very small.
Who
But
else?
thinking about it with classics professor, it's less.
Who else? All right. So for those of you who answered bus driver or truck driver, what did you went through your heads?
There are
Wait, for those of us who went through.
For those of you who answered truck driver instead of college professor, what went through your heads?
there are far more truck drivers than Ivy League classic professors, and just picking a person, regardless of what their description is, the odds are that they're going to fall into the category that is significantly larger.
All right, cool. So that's another case of base rate neglect in action once again. And then for the last question here, how did you decide whether there are more letters in the dictionary, more words in the dictionary with K as the first or third letter?
I was thinking that I don't know if there's any meaningful way of distinguishing which one is more likely, other than that there are going to be at least a handful of 1- and 2-letter words that start with K. Or I guess there is no 1-letter word starting with K, but there would be at least a few 2-letter words that would bias it slightly towards the first letter.
Anyone else? Want to share your thoughts? All right, cool. Well, I think that gives us this. So all of these phenomena, I think, underscore this problem of base rate neglect, which is not the whole of our issues with statistical reasoning, but I think a substantial part. And so just for the purpose of keeping this talk within a reasonable time frame, I'm just going to limit the talk to that. That being said, each of these studies was demonstrating a unique fallacy or psychological construct that Tversky and Kahneman have identified. The first, as I mentioned, is this concept of conjunction fallacy, where more information often leads us to make this conjunction despite it being statistically less likely than it, always less likely than it. So the second is an example of something Kahneman and Tversky call the representativeness heuristic. And this is the idea that when deciding how likely does object X belong to set A, if we were to do it formally, so we have object X relative to set A, question mark. So let's say that there's we have in our mind some exemplar of what typical element of set A is, and let's say it's that. And so if we've got X, and let's say that we've got X, or X, or X, which of these is most representative of this? Basically, what fits our idea of an exemplar most? And if it fits, then we say yeah, it's part of set A, regardless of the base rate likelihood that it actually is part of set A. But it seems right. It feels like it looks so close to in my mind what this exemplar is that we choose. The third phenomenon here is something called the availability heuristic. And this doesn't have so much to do with our concept of exemplars and how we deal with sets of objects, but about what information is immediately available to us when recalling from memory. Like basically when you remember, the process of remembering something has to go through 3 stages. You first have to encode the information correctly. And if you don't encode it in any kind of short-term memory or whatever, it's gone. And it just never is. And then there's deep level encoding, which is actually taking it from your short-term memory and putting it into long-term memory. And if something fucks up there, the memory could either be distorted or it goes away. And then there's recall, which means you have to call it up from long-term memory and put it into your active, usable memory and deal with it. And if something screws up there, either the memory is altered or there are oftentimes there are things that prevent you from recalling an item. So the availability heuristic capitalizes on things that are easiest to be encoded and retrieved, and advises against those things that we can't really retrieve all that easily. And so we remember a lot more words in our daily lives that have K as the first letter because we don't think about words that have K as the third letter. We aren't looking for that information, so we aren't encoding it into our memories. And so most people tend to answer that there are more words in English with K as the first letter than the third. But you guys are right. K is definitely, there are a lot more instances of K as the third letter than the first. But which information is more available to us? Letters that start up words all the time. So these are, I think, 3 really powerful pieces of evidence that Kahneman and Tversky have something right. That we're clearly not, like, the concept of using this idea of base rate or something doesn't even occur to us as an option to take. We just go with the information that we have and use an intuitive judgment there. And so what we're seeing there is a logical thought process that isn't centered in statistics. And so whatever kind of reasoning we're using doesn't seem to be statistically based. Further really strong evidence for this view is that when you try to debias something, and debiasing is basically trying to extinguish a mental model or thought representation or anything that isn't the behavior by repeated training showing that it's not the case or punishing its case. When you try to debias statistical reasoning fallacies, it's really hard to do. And while you're able to get some immediate improvement, like people, so the test this one pair of researchers did was they had 2 groups of people, and one of them learned there were 3 groups of people. One of them learned abstract statistical rules, such as this whole base rate thing. Others learned specific examples of base rate neglect and why it's wrong and what the normatively correct answer is. And then another group learned both abstract statistical laws and concrete statistical examples. They tested them a little while later, and the groups that received training did better than they did before. But then you test them like a day later, and a little while later than that, the debiasing has no effect. They keep making these same statistical fallacies again and again and again. So what's really remarkable about this is that when you do the same thing for logical fallacies, and this does raise the interesting question of are logicians smarter than statisticians? When you try to debias logical fallacies through abstract, concrete, and joined exemplars, you do make headway. And it's not huge, but you're able to debias those kind of fallacies, which again leads some pretty strong, to me at least, suggests pretty strongly that there is, that either our logical reasoning is somehow, our normal logical reasoning is somehow separate from our statistical reasoning. So that's a lot of the evidence for the Kahneman and Tversky side of things. But again, I mentioned the people who talk about bees.